Welcome and thank you for joining us this evening. I'm Fabiane Gonçalves and I'll be the facilitator tonight. This webinar is co-sponsored by Mass Energize and the Plug-in Metro West program, which is a 7-town effort to electrify homes and communities in the Metro West region. Before we get started, please take a minute to answer this poll you're gonna see on your screen right now. Right. Thank you everyone for your responses. Tonight, we're gonna hear from two speakers, Bob Zogg, a heat pump expert from the Heat Smart Alliance, and Kit Wu from the Laminar Collective, who conducts research on heat pump installations and negotiates pricing with contractors. After their presentation, we will have time for questions. If your question isn't answered during the presentation, feel free to raise your hand during the Q&A session or type your question into the chat at any time. With that, I will turn it over to our presenters, and I believe Bob is going to be the first speaker.
Yes, I'm Bob Zogg from the Heat Smart Alliance. Thanks so much, Fabiani. And as Fabiani mentioned, I'm joined by Kit Wu of Laminar Collective. I'll do most of the talking, but we'll leave the hard questions for Kit at the end, so he'll get his time. With that, let's get started. I'd like to briefly introduce the Heat Smart Alliance. Our mission is to reduce carbon pollution by accelerating the adoption of energy-efficient heat pumps in Massachusetts homes. We consider applications of home heating and cooling and water heating. We're an all-volunteer organization. We have over 135 members from 55 Massachusetts communities, and we're growing. Our approach is to educate through events like this and through our website. We also provide one-on-one coaching to homeowners who wish to consider heat pumps for their homes, in certain towns at least, and we collaborate with like-minded organizations. And just to keep ourselves neutral, we do not accept donations or referral fees from installers or manufacturers. Okay, Kit.
Sure. Hi, I'm Kit. You can see me on the very top of that little team section right there. I run Laminar Collective. We do a lot of research on heat pump installations, and specifically, we are trying to make sure that heat pump installations are available at an affordable price. To do this, we conduct a lot of benchmark market studies, but we also do a handful of installations ourselves that we directly project manage, just so we can get down to the details and pull back the curtain on equipment prices, consumable prices, and everything that adds up to the numbers you see on a quote. We're based in Cambridge. With that, I'll go ahead and leave it to Bob.
Okay, thank you, Kit. So why should you consider heat pumps for your home? Let's first look at how we use energy here in Massachusetts. This pie chart on the left shows that almost 30% of our energy use in the state is for our homes, and that does not include our vehicles. As we break that down, fully 80% of that is for home heating, home cooling, water heating, and clothes drying. And that 80% can all be handled with heat pumps. So heat pumps can make a real difference. If you'd like to decarbonize your home, there are 3 basic steps. First is to weatherize. That means to insulate and air seal your home to the fullest extent practical. Most of you will have access to a no-cost home energy assessment in your community, and that is a great place to start. Step 2 is to electrify. That means switching out your fossil fuel consuming appliances and equipment and replacing those with energy efficient electric appliances and equipment, and that is where heat pumps come in. And step 3 is to make sure that you use renewable electricity. You certainly can put solar panels on your home to do this, but you do not have to do that. We all have access to 100% renewable energy through the grid. Okay, what is a heat pump? A heat pump is basically a device that moves heat from a cooler place to a warmer place. We all know intuitively that heat flows naturally from warm places to cool places, but if we want to reverse that flow, we need to use a mechanical device and we need to add energy to do it. And that's what a heat pump does. While we don't call them heat pumps, we already use the same basic technology in our home and our refrigerators, our dehumidifiers, and our air conditioners. Heat pumps are available for home heating and cooling. So one piece of equipment that does both functions of heating and cooling. They're available for water heating and also for clothes drying and even pool heating. This simple illustration shows how the efficiency of a heat pump can be greater than 100%. In this example, and it's just an example, we're using 1 unit of electricity from the grid to pump 2 additional units of energy from the outdoor air, which delivers 3 units of energy into the home. In this case, the efficiency would be 300% or 3. And some heat pumps can be even more efficient than that. And just as a reminder, heat pumps provide both heating and air conditioning, so you get both functions from one piece of equipment. What are the benefits? First and foremost, a substantial reduction in carbon pollution, and we'll show a chart in just a second to quantify that a bit. They're also safer. There's no risk of carbon monoxide poisoning or any explosion from flammable gases in the home. And a difficult to appreciate benefit is comfort, year-round comfort. As this illustration shows, this gold line shows how most heating and cooling equipment performs. It cycles on and off, and that results in temperature swings. Modern heat pumps are variable speed, which means they can tune in to just the amount of heating and cooling your home needs and maintain a very uniform temperature in your home. It's really hard to appreciate until you've experienced it. Okay, here's an example showing the carbon pollution associated with a typical 2,000 square foot home. This is not your home, but it is representative. And it's comparing the carbon emissions associated with various heating fuels and comparing them to 2 types of heat pumps, which we'll talk about in a minute, ground source and air source heat pumps. As you can see, the reductions in emissions are substantial. And the magic of electrification is if you get your electricity from 100% renewable sources, those emissions go to virtually 0. Okay, so what type of heat pump is right for your home? And every home is different. First, we're going to talk about the heat distribution system in your home. And just to make sure we're all on the same page, we'll go over this briefly. The 2 most common types are first, hydronic. That can be hot water or steam, where you'll have a boiler in the basement. You typically baseboards for hot water. If you have an older system, it might use a steam radiator. It could also use radiant floor heating in some cases. The other common system is forced air, where you'll typically have a furnace in the basement. You may have an air conditioning unit with it that provides heated or cooled air through ductwork that distributes the warm or cool air to various rooms in your home and returns it back. So if you have a hydronic heating system in your home, you probably do not have any ductwork. The most straightforward approach to using heat pumps is to use what we call a ductless mini split. And this has an outdoor unit and an indoor unit that's mounted in the room that you'd like to heat or cool. And the two are connected with just a couple of copper tubes, so there's no ductwork required. A variation on this is what we call a ductless multi-split system, where you'll have a single outdoor unit connected to a multitude of indoor units. And in either case, while the wall mount unit is the most common indoor unit, you can have a ceiling recessed unit, you can have a floor mounted unit, and you can even have a horizontal ducted unit that can distribute heat or cool air to adjacent rooms. And most people choose to keep their fossil fuel system as backup in extreme conditions. Okay, if you have a forced air distribution system, the most straightforward approach is a central air source heat pump. The outdoor unit looks a lot like the outdoor unit for a central air conditioner. The only difference is that it's typically mounted on a pedestal to keep it out of the snow. Now, there's two variations we'll go over here for the indoor piece. In this example, we're showing what's called a hybrid system, which has a furnace built into it for backup heat, which uses fossil fuel. But on top of that, instead of an indoor air conditioning unit, there's the equivalent for the heat pump, a coil mounted here that can provide both heat and cool to the air. So you have either piece of equipment can provide heat, and the heat pump can provide heat or cool. As an alternative, you can have an all-electric system, which has, again, the indoor unit, in this case, will not have a furnace packaged with it, but instead will have typically electric resistance heating elements to provide supplemental heat. Or it can be without any backup heat at all and just use the heat pump. For the ultimate in energy efficiency, there's the ground source heat pump, also called the geothermal heat pump. This gets very efficient because instead of extracting heat from the outdoor air, it actually extracts heat from the ground and pumps it into your home. And the ground is warmer in the wintertime than the surrounding air, so that gives an efficiency advantage. The indoor unit looks a lot like the air source heat pump indoor unit, but in this case, the whole entire heat pump is packaged in this box that sits in your basement. One caveat here, your existing ductwork needs to be suitable for a heat pump, and it should be well insulated and sealed as well. And an HVAC installer can determine if your ductwork is suitable for a heat pump or can be made suitable. Just a bit more on ground source versus air source heat pumps. The advantages of ground source: there's bigger incentives available, and they're 50 to 70% more efficient than air source. There's better outdoor aesthetics after you have the system installed. There's no mechanical equipment sitting above grade outdoors. And the heat pump itself is factory packaged, which means there's less chance of a refrigerant leak. For air source, it's a lower cost option. There's no disturbance of the landscaping for drilling boreholes that are required for the ground source. Doesn't require much space outside your home. And currently there are more options available in ductless models. Currently, the ground source heat pumps are really only suitable for forced air systems. Let's not forget about water heating. Heat pump water heaters, also called hybrid water heaters, can provide over 60% savings on energy and carbon pollution. They can provide fast payback compared to conventional electric water heating, and they can be installed by plumbers or HVAC installers. Now, any plumber can install a heat pump water heater, but that doesn't mean any plumber will, and you may have to shop around to find one, but more and more plumbers are providing heat pump water heaters. Okay, we're going to talk a bit about cost. I'm sure that's of interest to everyone. And first, we'll start with Kit.
Hey guys, so I'm going to keep it really simple over here. We've been tracking seasonal costs for the past 2 years in the Massachusetts market. And what I have listed over here is sort of a diagram, a little chart, if you will, that generally shows you the trend of what I'm expecting the 2025 market to look like. Again, these are the initial cost of installation. This does not have to do with the ongoing cost of running the heat pump, but it is specifically talking about what you're getting quoted if you have a contractor come to your house. I'm talking about air source heat pump setups over here, and I am giving you an example of a single family colonial home with new ductwork that needs to be installed. And that's the number you see there on the left, a range between 28,000 to 35,000. Typically, prices peak in the summer. Perhaps not surprisingly, when there is a heat wave, more people call contractors. And when the weather gets a little bit better in September, the prices start dipping down a little bit, as contractors that are a little bit more affordable become a little bit more available, instead of being constantly booked out throughout the summer. And the prices keep on sloping down a little bit. And based on what I've seen in 2023, when Mass Save had a quick change to its policy, you might experience a little bit of a rebound as people turn on their heaters and some people realize, oh, wow, I need to fix my heating system before it gets cold. And then, of course, past December, it typically slows down. And I define the slow season between January and tax day. Perhaps not surprisingly, people don't like to drop a lot of money on new systems before tax day. So that's the initial upfront cost. I'll go ahead and give it to Bob, pass it back to Bob to talk a little bit more about ongoing costs as well as financial incentives.
Thanks, Kit. I'm only going to go through this briefly because there are so many incentives available. We could talk for hours. But I will provide links and you will get a copy of these slides after the presentation so that you can look up more details. If you are eligible for the Mass Save program, and many of you are, you can get rebates for air source heat pumps up to $10,000, depending on the type of system you put in, up to $15,000 for a ground source, $750 for a heat pump water heater, and you can get a zero interest loan for $25,000 to help you with all that. And if you're income qualified, there's additional incentives as well. Higher incentives are available. Federal Inflation Reduction Act. Now, we all know that things can change at the federal level, but this is what we have today. We have up to 2,000 for air source heat pumps and heat pump water heaters. There are plans for additional income-based incentives as well at the federal level. Now, a relatively new addition here in Massachusetts is the Energy Saver Home Loan Program. And this does require that you have a number of energy savings measures that you're installing that will save at least 20% of your energy. There are income qualifications based on area median income, but these are pretty generous and will cover quite a few people. And this Energy Saver Loan Program works a lot like a second mortgage. And here are the promised links where you can get more information. Again, a lot to digest there, but for today, we'll just leave it at that. Okay, now we're going to look at the typical heating costs for a heating season for the same 2,000 square foot home we looked at for carbon emissions. And I want to point out that we're using a 33-cent per kilowatt hour electricity price for making these comparisons. If some of you live in a town that has a municipal light plant, you might be paying half this amount for electricity. So your heating costs for heat pumps could be half what we're showing here. Now, the order of the bars is a bit different in this chart compared to the carbon emissions. As you can see, natural gas is a little cheaper than an air source heat pump to operate. That's been true for a while, but actually this past winter, fuel oil costs dropped enough that fuel oil is coming in just under the cost of an air source heat pump. Ground source still beats both of these based on current prices. The important caveat here is that we really would like to know the energy costs over the life of the equipment. And we don't know what those are going to be. Every time I plot these charts, every 3 months or so, they look different. So my advice is not to put too much on this in your decision-making process. The differences are rather small in most cases. But we do like to share it and give you all the information we have available. Okay. If you like to do spreadsheets and financial analyses for making purchases, that's super, but be sure you have the correct inputs. When you're looking at the first costs that, for example, what Kit just went through, be sure you're looking at a cost difference. You're going to have to replace your conventional equipment anyway. So it's really the difference in cost that you want to look at, and you need to look at both the cost of heating and cooling equipment. Be sure to include all the incentives that you're eligible for. And depending on your value system, you may want to assign a price to carbon pollution. You may also want to consider the improvement in home resale value, and don't forget about the comfort improvements you'll get. And as I just mentioned, we have to accept the uncertainties about future energy costs. So what should your action plan be? A great time to convert to a heat pump is when your heating or your cooling equipment is getting old, which generally means over 15 years. For water heaters, they don't last quite as long. Typically 7 to 10 years is a decent life for a water heater. This is really important to get ahead of things. If you wait until you have an equipment failure, you're going to be in an emergency situation. You're going to be very rushed to replace that equipment and get up and running again. And it's going to be very difficult for you to consider heat pumps. You could end up locking your home into fossil fuels for another 15 or 20 years. So please don't try to get the last mile out of that aging equipment. Think ahead, plan ahead, and hopefully replace before failure. Another great time is if you'd like to add air conditioning to a home that doesn't have it. Heat pumps, as I mentioned, provide very efficient heating and cooling. And certainly if you're planning an addition, a major renovation, or a new home, heat pumps can serve 100% of your heating and cooling needs and are an obvious choice in those situations. To get started, there's a lot of places you can get information, but this link will take you to the Heat Smart Alliance website, where you can study up a bit more. As I mentioned before, you get a no-cost home energy assessment if you're eligible for Mass Save. I put a link here for that. And if you have coaching available in your community, certainly take advantage of that. This link will take you to our website, which lists the communities we're aware of that provide coaching. It may not be a complete list, but we'll certainly give you links to the communities we know about that have coaching services. And when you're ready to get quotes, we recommend getting at least 2 or 3 quotes. You'll learn something different from each installer. And then when it comes time to make a decision, look at the big picture, the equipment offered, the reputation of the installer, in addition to the first cost. It's not just a commodity purchase here. And that concludes our presentation.
Thanks, Bob. Kit, do you want to add anything?
I think I will be here for the next 15-20 minutes to answer any question anybody has. I think we've spent an unhealthy amount of time at Laminar Collective getting into the brains of a contractor. So any cost questions you have, happy to answer them.
So before we go over the questions, is there anyone here who has a heat pump system at home and would be open to sharing their own experience? All right. Tom, yes.
Yes, we have a a heat pump. It's a little unusual because it's fairly old now. It was activated in February of 2006. And it is a ground source heat pump. So let's see, it was to replace an oil burning hot water system. And that system had been giving us trouble ever since we installed it, actually. It was the flue wasn't working correctly, so we were getting, smells in the house from that a bit. And but it provided good heat. But then it broke down. It broke down maybe 5 years after we first installed it, needed a new boiler. Shortly before we decided to put in the heat pump, we were told we would need another new boiler. And that was like less than 20 years. Lots of major maintenance on that, it seemed to me anyway, on that system. So we took the plunge and got rid of it entirely. We did not keep it as a backup, and we installed had the ground source heat pump installed with a fairly local guy who had done other similar heat pump systems in other towns in Sudbury where we live. Anyway, it's been great. It's been very low maintenance. The worst thing that's happened, well, there's one bad thing. It lost its refrigerant once, for no known reason, but it did and had to be replaced. And then twice in that time period since 2006, I guess, we've had to replace the well pump. Since this is a water well, provides the source for the heat pump. Maintenance. It's very reliable and been a good system for us, and it saved us money. I recently calculated how much money it would have saved, how much more money we would have saved in oil. I don't know the number right now, but it was a lot if we'd stayed with the oil system. And we had to replace that anyway, so that was a wash. Anyway, I guess that's what I have to say. Any questions, I'll try to answer them.
Tom, I got a question for you. How did your system perform last year and also in 2015? I'm just thinking of the two coldest years that I have in my memory.
Well, I try not to push it too hard when it gets really cold, but because you'd say it'll run all the time on really cold days. And I have a backup. I have a wood stove that I actually use besides keeping the house cooler. But that is my backup, the wood stove. And actually, one time when we lost power entirely, we kept the house like in the 50s with the wood stove.
Nice.
Mm-hmm.
It's pretty awesome.
Anyway.
Thanks, Tom. Anyone else? I can see everyone, but I think we can move on to the Q&A. Again, you can either raise your hand to ask questions or submit them in the chat. I will let Bob and Kit lead the Q&A session. Questions?
By the way, if anybody wants to drop questions inside the chat, I will happily respond in the chat for everybody to see as well.
Okay.
Bob, I'll let you take the first stab at this first question.
Does it work well to keep the house relatively warm in cold weather? We have a disabled family member that needs it warm. Okay. Yeah, you need to set the thermostat where you're comfortable. We don't, and especially if you have special needs. I'm getting older, and I need the thermostat a bit warmer. And assuming that the heat pump is sized properly for your home, it shouldn't be a problem, and I wouldn't worry about it.
You want to go, Paul?
Well, I'll see if I can get it. I don't want to type it in. See, they're typing it
Yeah,
in.
but hold your arm up.
Okay, I
What?
did.
Wait.
Okay, there's a question for Tom. How much did the 2 repairs cost?
Oh, that'd be hard to remember. Been a long time ago.
Yeah.
For me?
Yes.
Yes, okay, the repairs. I remember the well pumps are fairly expensive. Um, I I was surprised at that. I didn't really know. I think if I was going to do a ground source system now, I would probably maybe Bob can talk about this or Kit. I would probably use the one that is not a deep well that just uses a buried tubing that goes, I don't know how deep it goes, 10 feet or something. I'm just guessing, I don't know. To avoid the possibility of losing the well pumps. And the well was pretty expensive to install. At the time, it was like, I think it was like $10,000 to put in the well. And it's probably a lot more now. But anyway, I don't remember how much it costs when the refrigerant was lost. I just don't remember. I don't remember it being terrible though.
If I can
I
chime
think
in.
what they basically
Oh.
did is they put in something like it's my understanding is they put in some kind of leak stop thing into the existing system. So they did not try to isolate the leak and find out or replace the transfer coils or anything like that. They just put some kind of leak stop thing in there and put more refrigerant in, and then it's been fine ever since then. That was a long time ago.
Yeah, go ahead, Kit.
Oh, I was just gonna go ahead and say, in my experience, I've seen a couple of different types of repairs. Dealing with leaks is one of the most common one. And if you want just a number for that, R410A is maybe about 40 to 75 a pound. Realistically, the cost of replenishing refrigerant is not going to be that much. Fixing a leak, however, is going to take a little bit more time in labor cost, because if you want to fully isolate the leak, you need to recover all the refrigerant, you need to charge the system with nitrogen to basically really see detect where the leak is. And then you have to, bring a spray bottle of bubbles and you try to, do the bubble test for every single point in the system where you have a connection between a flare and the actual system. Realistically, a skilled person can figure this out in a day. The cost of servicing a system that has been leaking refrigerant is not going to be super high. Now, that being said, if something is wired incorrectly and your circuit board has, burned up and you need to replace the circuit board, that's going to take a little bit more time. But I think that also ends up getting covered under a lot of equipment warranties.
Yeah, and I just wanted to add, there's actually several ways that ground source heat pumps can be coupled with the ground. And Tom, I'm not sure whether your system is closed loop or open loop. In both cases, you would use a well or, in the latter, a borehole. The open loop systems, which are uncommon now, actually often use a typical well water and pump the water out and into the heat pump and back into the well. The closed loop have a pump that's actually mounted with the ground source heat pump, and it actually circulates water through a tube down into the borehole, and so it's not actually interfacing with the groundwater. And I expect that would be a little bit less expensive repair. The horizontal systems, which most people think of when they think of a ground source heat pump, where you lay coils, you excavate a large area and lay coils down, are less common in New England because we have so much ledge. And even though it seems counterintuitive, the drillers love drilling in bedrock. They love drilling granite. They don't need any casings, and they just drill right down through it. So our bedrock is ideal for going vertical, not so ideal for going horizontal.
Paul Remington, I think you have a question. I'm sorry I missed that. I don't hear you.
You're muted, Paul.
I'm trying to unmute here. It says that I'm unmuted.
Paul,
Can you
you're
hear
good.
me yet?
You're good, you're good.
Am I good? Can you
Yeah.
hear me?
Yes.
Yep.
Oh,
Okay.
good. Okay. So currently our house has a forced hot water oil fired system and an air conditioning system outside, which is getting a little bit long in the tooth. And so the thought we had was that we would replace that with a one of these systems. And I'm kind of wondering, is that feasible? And what would the cost be, for example, if the system failed and we just said, well, we're going to go ahead with a regular old air conditioning system, replace the compressor and the evaporator and so on, instead of going with a heat pump system. And the other question is too, that we have ducts, of course, that empty air into the ceiling of all the rooms, and I'm not sure whether that would be compatible with heating. Have any thoughts about that?
Yeah, so it sounds, Paul, that like your home was retrofitted with ductwork for the air conditioning system. Yeah, that's actually reasonably common. And the answer is, of course, it depends. You need to have a qualified installer look at it and make sure it's up to snuff. But you know, based on what you've said, I don't see any big problems with putting it in, and it's quite common for people to do exactly what you're considering. Now, you know, there's some people who seem to be really wed to hydronic heating, and they're worried about going to forced air heat, which is what you would be doing for most of your heating. But I've coached people who did exactly what you're considering, and they actually preferred the forced air heat. And again, with the variable speed, you don't get the blasts of, cold air in the summer when you're air conditioning, for example. You get just a little puffs of cool air. You can set the thermostat at 80 degrees if you want and wear shorts and t-shirt, and you're just comfortable. Same thing happens in the winter. So it is a very comfortable heat. So this should work. I'll let Kit speak to the question about what it might cost.
When it comes to ductwork, usually what we encourage people to do, well, actually, we actually just did a field experiment this spring. We took 12 houses, and for each of those houses, we did what we describe as a ductwork performance test. And I'll go ahead. I've dropped a link over there. The article that we wrote is a little bit technical, but long story short, we push a bunch of air through the ductwork, and we basically see if there's any leaks. We did this for about a dozen households with existing ductwork. For one of the households, we found that the ductwork is too small and incompatible with a heat pump. That one ended up being a triple decker, where you have ductwork going from the basement all the way to the top. For the 11 remaining households, about 6 of them had leaky ductwork, and about 5 of them had ductwork that required no remediation. So I'd say, based on what we've seen in the field, most people do have ductwork that is relatively compatible with a heat pump, but there might also be cases where you have a lot of leaks. For us, I think, we encourage people to talk to HERS raters if you really want to get to the bottom of whether the airflow is right or not. But if you can reuse the ducts, it dramatically lowers the cost.
I see we have a question from Deb regarding well, let me ask we'll go back and forth between the chat and the room here. So Deb is asking, she heard that heat pumps don't work real well on cold days, and it might be better to keep the existing forced hot water system that they have for the cold days. And it may also, she's heard that may be more affordable to use forced hot water, the heating system on those cold days as well. That can be true. Again, there's no reason that the heat pump cannot be sized to cover your whole heating load, but sometimes there's practical constraints, like certain rooms may be more difficult to heat than others, or more expensive to put in heat pumps and may not be worth the extra investment. So, if your system is there and it's working well, why not keep it? And yeah, depending on the fuel you're using, heat pumps tend to be more efficient the warmer it gets. So you might have a point where if it gets below a certain temperature, even though the heat pump can still do the full heating job, it might be cheaper to use fossil fuel below that temperature, and cheaper to use the heat pump above that temperature. And if you want to keep track of all that, you can. You might save a few bucks at the end of the year. I don't think you'd save a lot of money, but you might save a little bit. Melanie, go ahead.
That was a waffle answer.
Pardon?
That was a waffle answer.
Melanie? Okay, there is another question. How hard is accessing below ground equipment for repairs?
Well, it's the bad news. It's hard to access. And just to be clear, what's below grade is tubing. It's not actual mechanical equipment. And even though it might be hard to get to, the good news is it's designed to last for 50 years. And they're very careful about putting it together, making sure it's leak tight before anything gets covered up. So it's really just very durable tubing. And there's really very little likelihood you'll ever have to excavate it and do a repair underground.
Can I actually oh, sorry. Melanie, let's cover Melanie's questions first, but then after that, at some point, I want to go back to Deb's question and send something potentially very useful. All right. Melanie, you're off mute, but for some reason, we still can't hear you.
Yeah, we can
I'm
hear you.
sorry, you may have to put your question in the chat, Melanie. We're not hearing you. There is a question from Bill about how can we evaluate future electricity rate increases that will be needed to upgrade the local power distribution systems. Yeah, this is
Ooh.
yeah, and these are political considerations, policy considerations. We don't know what direction these costs are going to go in. Yes, we do have to upgrade our electricity system, but we're also looking at ways to be a lot smarter about how we're using our electricity. And there's actually some effort underway in Massachusetts to look at lower electric rates for people who are using heat pumps. The argument being that, at least currently, when we're using electricity for heat pumps, it's during periods where it should be a little cheaper to provide that electricity, and therefore people using heat pumps should get a lower rate. So tough to call how that will all work and where the costs will go, but part of the plan is to make the grid a lot smarter.
I can also add a little bit to this. We actually did our benchmark research study this particular spring at the house of somebody who signed up for my newsletter in Somerville. It turns out that the person who signed up works at the Department of Energy Resources, and she actually analyzes grid planning under different scenarios of electrifications. And the gist of the matter is that typically the peak demand for the grid at the moment is during the summer. The more that people shift over to heat pumps, the more that peak. Right now, the other way to say it is that in the winter, electric demand is not peaking. And the cost of making upgrades to the grid primarily has to do with accounting for those peak demand days in the summer. So the more you deploy heat pumps in the winter, the more you shift that peak away from the summer. And because you're using the capacity that's already built into the grid for those hot summer days, realistically, we don't need to build new infrastructure to account for the extra demand on the grid during the winter, because there's relatively low demand anyways during the winter. That is a very long way of describing why there is a current conversation at the Department of Public Utilities right now about bringing lower electric rates, specifically for people on heat pumps. Maine is also taking a look at the exact same policy, but that's also because Efficiency Maine, their version of MassSave, is a little bit farther along the deployment curve than we are.
Thanks, Kit. So we still have time for questions, but please answer these 4 questions you will see right now. Thank you. Let's go back to the questions. I think, Bob, do you want to answer the next?
I'm sorry, Kit, you wanted to mention something in addition to Deb's question, I think.
Oh, yes. I was actually going to go ahead and show you this useful website, the Department of not Department of Public Utilities, I'm sorry, the DOER, Department of Energy Resources from the state, publishes every single winter. So this is the household heating cost report that they release maybe about November of every single year. And a part of this particular report is this useful bar chart right here, figure 2, that describes on average the heating costs of comparative fuels. Right? So oil over here is right around the same as natural gas, which is right around where electric air source heat pumps are. Geothermal is going to be lower than all of these, but it's not on this particular chart because it's not deployed as widely as all the other fuels. Propane is much more expensive, and electric resistance is even more expensive than that. I've made some annotation to explain why these error bars exist. And they primarily exist because if you take a look at different houses, you'll see all sorts of different gas furnaces and oil boilers, right? Sometimes you'll get a really, really old furnace. Those furnaces are probably closer to maybe 83, 84, 85% efficiency. The newest ones, the high efficiency gas boilers, are going to be around the 90s for their efficiency. Same deal with boilers. If you have an extremely old boiler that was installed in 2000, that is probably less efficient when it comes to converting heating oil to heat. And the same deal with air source heat pumps as well. If you have a non-cold climate older model from 15 years ago, it's probably more inefficient. But the cold climate models right now that Mitsubishi, Daikin, and Fujitsu are releasing, they tend to be the more efficient ones in the market. So that also plays a factor into how much the costs are on the cold days.
Yeah. Thank you, Kit. I just want to also point out that KJ put a nice testimonial about his heat pumps in the chat, if you haven't seen that already. And he also brought up a very important point that they paired their heat pump with solar panels, and that can be a great way to lower your effective cost of electricity. So many people find that works out well for them. There's a question from Melanie. My house is 47 years old with uninsulated ducts in the walls. Can I still use a heat pump? In all probability, yes. And presumably you mean with your existing ductwork. And again, talk to your installers about it. The fact that your existing home is not perfect, and maybe it's not practical to insulate or air seal those ducts. Maybe air sealing will be practical, maybe insulation's not. You may lose a little efficiency, but you'll still come out ahead in terms of certainly in terms of your carbon footprint, and you should still come out ahead in terms of comfort. The installer will just have to allow for a little bit of more heat loss in the design load calculations.
Yes, Nina is asking, can you approximate the increased cost to a homeowner's electric bill after installing a heat pump?
Well, it's tough to give an exact number, but I can say it can be very substantial. And you may recall one of my earlier slides, I showed that fossil fuels, well, heat pumps can supply something like 80% of the energy your homes use. And if you replace your heating system, your cooling system, your heating system and your water heating system with a heat pump, you're replacing a huge amount of your fossil fuel use with electricity. So, before you did the heat pump, you were only maybe 20% of your energy was from electricity, and now you're getting 100% of your energy from electricity. And so that's a big increase. So you have to remember to subtract off what you're saving in fossil fuel. Sometimes people forget to do that. The other thing is that the bill can be very skewed. Your electric bill can be very skewed to the winter time. The January, December, January months tend to be quite high for heating costs with a heat pump. But then when you average them out over the year, things look normal. But you do have to be prepared for that change in how your monthly bill might look.
Yes, Paul? You need to unmute.
Can you hear me now?
Yes.
Okay, good. So far, the discussion has been about heating. If I were to replace my air conditioning system now with a heat pump, would I expect costs to be comparable, cheaper, higher? What would you think?
Well, in terms of your cooling season costs, I would expect them to go down because the modern heat pumps should be much more efficient than your current air conditioning system. And as I mentioned, it should also be more comfortable for air conditioning.
Right. Thank you.
And by the way, Kit, I'd be interested in your opinion on this, but it's my sense that if you were really to try to match comfort with a conventional system, say a central air conditioner and a furnace, you can spend a lot of money and you can buy, a furnace that has modulating capacity, and you can buy an air conditioner that provides variable speed, the same as a modern heat pump. But by the time you purchase that, especially considering the incentives available, you'll spend more on the conventional system than you would on a heat pump.
Yeah, that largely is playing out in our data as well. But obviously it also matters seasonally, right? I think typically we see sort of like a spike in demand in a lot of retrofits around the fall season. And I think my theory is that a lot of people, summer tends to be a more active home buying season. And a lot of people who have signed up for our research newsletter tend to be new homeowners that just bought a house and they notice the oil tank in the basement. And they're like, all right, I'm going to do a bunch of renovations anyways. This oil tank is here in my basement and the boiler is, gosh, like 25 years old. I'm going to replace it. And so I feel like in situations like that, where, they're replacing the existing heating system and they already want a new air conditioning system, it totally makes sense. It is less expensive in that scenario to just get one good system rather than two systems that, have to be stacked on top of one another. I think contractors, where there are existing furnaces, maybe they're a little more comfortable adding just the AC component, but realistically, if you're going to replace the heating system anyways, right, it's almost always going to be less expensive just getting one good heat pump.
I see Tom has a question. Do heat pumps include electric resistance for backup or to supplement the heat pump? They can, but they don't have to. That depends on the system you purchase. Now, for the ductless models, the ones that did not require ductwork, they do not have backup resistance elements in them, okay? Those wall mount units are strictly a heat pump. In the case of the central ducted systems, you can use electric resistance backup heat. You can use conventional fossil fuel backup heat, or you can go without backup.
Any other question? All right. Is there, okay. Question for Kit, I guess. Is there a website resource for helping us determine what brand or heat pumps might be better than others in terms of reliability, efficiency, etc.?
Oh boy, you should ask me that in 2 months because that is literally an intern project that we are about to do this summer. Every single brand is coming out with new models this summer season, and we are going to have an intern collect every single cold climate heat pump engineering submittal so that we can get the performance data and put it all on one single table so that it's really easy to understand. So, Deb, I encourage you to,
Okay.
send me an email at kit@laminarcollective.com, and I will let you know when we have that report out.
I have a quick follow-up question, if you have a minute.
Yeah,
So
I
I've
do.
also heard that, the refrigerants keep getting changed, it seems, every few years, they determine that the refrigerant is no longer allowed. It's not good for the environment or something like that. But now the current refrigerant that is being used in AC systems, heat pump AC systems, is more efficient, but also more flammable. I mean, and it seems like it changes every few years. How often? I mean, how will that affect our heat pump systems if we put one in and then they decide that the refrigerant in that model is no longer allowed?
Bob, you want to talk about this, or do you want me to talk about it?
I'll take a crack at that. They actually don't change refrigerants quite as often as it seems, but it does seem to happen, every decade or two, and for good reason. We want to protect the environment and use environmentally friendly refrigerants. Yes, there is a transition going on, in fact, this year. And this year you may get quotes with new refrigerants or with the existing R410A. But the EPA does think about the impact on people and the impact on the economy. And so it plans a long phase out period. So the refrigerant will still be available for repairs for quite a long time. It's possible towards the end of the service life, if you were to buy a heat pump with the old refrigerant today, you might, and you did have a repair in 10 or 15 years that required refrigerant, it might be more expensive then. And some of you may have had this experience with R22, which was the predecessor to R410A. If you have an air conditioner that's 20 years old or so, and you need to get new refrigerant, you may find it's quite expensive to do that and may be better off replacing it. My personal advice, not everyone will agree with this, my personal advice is don't worry too much about whether you get the new refrigerants or the old. Yes, the new refrigerants might be a little more efficient, but that really depends on the manufacturer designs the system. And yes, they are moderately flammable, but they're being very careful with how they design the systems, and there are safety requirements. The type, you could not light these refrigerants with a match and watch them burn. They would need a blowtorch to keep them burning. They do require quite a bit of heat, and then quite a bit of energy to ignite them. So my sense is they're very safe. And I feel that even with the moderately flammable refrigerants, I'm still way safer than I would be with fossil fuels in the home, in a system that's not nearly as well contained as the refrigerant.
The one thing that I have to add to this is that, you know, the funny thing is that the new refrigerant systems, right, R32 systems, they're already, they've been in use for years over in Europe. They're in millions of units in Europe and Asia already, and that the United States is actually kind of catching up to R32 at the moment. They've been out in the field, they've been proven safe in millions of homes. And again, you know, there's the simple fact that, you know, if the way that I think about it is if we are comfortable with natural gas pipelines in our towns and communities, and also going into our homes and pretty much every single room, every single kitchen in our communities, this is not, I mean, that's an order of magnitude more like flammable than what you're seeing over here in these closed systems.
If we have time for, I noticed there's a question in the chat about 100 amp electrical service and whether that can run a heat pump with things like an EV charger and electric dryer. It's possible. It could be tight. There are smart systems out there that sometimes are less expensive than getting a panel upgrade that can prioritize loads and allow you to connect more equipment than you normally would be to say 100 amp service. But yeah, this is a question you want to ask your installers when they come in. And there may be a way to accommodate it, or you may find that it gets expensive.
Right. We are out of time. So thanks again, Bob and Kit, for your presentation, and thanks to everyone who joined us. We're gonna send a follow-up email with the recording and the presentation and all the resources they shared today. Thank you so much. Have a good night.